Test test 1 2. Okay. Test test.
Welcome to the navigation training flight. I've engaged the autopilot to keep the aircraft level and on course, so please do not touch any input controls outside of the training commands you will receive. In this flight, we'll overview the navigation systems of the A10C and practice navigation procedures. If you find it hard to hear my instructions over the background noise, exit the mission and turn down the world and in-cockpit sound sliders to about 50% in the options menu. Increase throttle to about 90% core RPM to keep the aircraft above 250 knots indicated.
I have to do some real quick. Okay.
The A10C is equipped with a complex navigation suite consisting of a number of different systems. The oldest of these, originally installed on the A10A, is a heading attitude reference system, or HARS. HARS is a gyro platform navigation system that accumulates significant errors as the aircraft is maneuvered in flight. It can be reset accurately only in level flight and no acceleration. Because of these limitations, HARS is considered a backup system used in case of primary navigation system failure. The primary navigation system of the A10C is the Embedded GPS INS, or EGI, often pronounced IGI. The IGI integrates a traditional inertial navigation system, INS, and a global positioning system, GPS. Each of these two IGI components can function independently of the other. However, they are designed to work together to provide accurate worldwide position and flight navigation data. Finally, the A10C is equipped to home on traditional radio navigation systems such as TACAN, Tactical Air Navigation, ILS, Instrument Landing System, and ADF, Automatic Direction Finder. The primary control panels used to configure the navigation systems include the Navigation Mode Select panel, NIMSIP, on the front dash, and the Control Display Unit, CDU, on the right console. In this mission, we'll also work with the TACAN panel on the right console. In order to minimize the time spent head down configuring the instruments instead of looking up and out of the cockpit, the A10C features the upfront controller, UFC, below the HUD, and the CDU repeater page on the MFCD. These allow you to manipulate CDU data without having to touch the CD. Navigation information is displayed to the pilot on the HUD, the TAD and CDU pages of the MFCD, the CDU display, and the analog ADI and HSI instruments on the front dash. Let's begin taking a more detailed look at each component of the navigation suite. The NIMSIP located in front of the control stick toward the bottom of the front dash, is used to select the navigation system used to feed data to the instruments and what type of navigation points to home on. Specifically, the top row of select buttons selects between HARS, IGGI, and TISL, Target Identification Set Laser. You will generally use the IGGI as your primary navigation system, and you can see that it is selected by default.
Warning, autopilot.
Like HARS, TISL is an A10A legacy system that has been replaced on the A10C by the AN/AAQ28 Lighting 2 targeting pod. Along the bottom row of the NIMSIP are buttons to set the type of navigation points to home on. These include STR-PT, steer point, ANCHR, anchor point, TCN, TACAN beacon, and ILS, instrument landing system. During flight operations, you will usually navigate toward a steer point, so STR-PT will be the preferred selection. TACAN and ILS are used for airbase approaches and landing, and an anchor point is usually the mission bullseye. In review, the selections of source navigation system on the top row and the type of navigation points on the bottom row determine which system provides steering information presented on the HUD, ADI, and HSI, and toward what type of navigation point. The PTR switch is used to stow away the pitch and roll steering bars, as well as the course warning flag on the ADI. The two homing lights to the right of the select buttons indicate VHF or UHF radio homing when either radio is used in ADF mode. The next item we will consider is the TAD page, currently displayed on the left MFCD. The TAD includes symbology for your aircraft, currently in the center of the display, a flight plan course line, currently running along the center from top to bottom, and various other indications, which we will discuss separately. To work with the TAD page, we need to set it as our sensor of interest, SOAR. To do so, press and hold the HOTAS Coolie Hat left command or the H key on the keyboard. Alternatively, you can press the TAD OSB 15. When set as SOI, the display will become inscribed in green. Okay, now that we have control of the TAD, let's first scale the map out so we can see our entire flight plan for better orientation. To increase the TAD scale, press the HOTAS Demons down command or the N key on the keyboard until the flight plan is visible, 3 presses in this case. You can now see our flight plan consists of 6 waypoints, indicated by square symbols connected by course lines. The currently selected waypoint, called a steer point, is colored yellow instead of green. Also note the TAD range in the upper right corner of the display, currently 40, and the map scale. The range value indicates the range to the outer ring of the display. It's important to understand the concept of waypoints. Waypoint is the generic term for all navigation points of interest, which can include the current steer point, all flight plan waypoints, mark points, and anchor points. Generally, you will be following a flight plan that consists of a number of flight plan waypoints, one of which will be usually selected as your current steer point. Using the CDU, you can edit, create, and delete waypoints either as part of a flight plan or as independent waypoints. Let's try performing the most basic navigation function of cycling through the flight plan waypoints to select a current steer point. This can be done either by pressing the steer rocker key on the UFC or the steer switch on the CDU. I've highlighted both and you can try pressing both. Watch the TAD display in the data block in the bottom right corner of the HUD as you cycle through the flight plan waypoints. Press the spacebar key to proceed once you cycle through the waypoints. can also cycle waypoints by using HOTAS controls. To do this, first make the HUD soy by pressing the HOTAS coolie hat up once or the U key on the keyboard. An asterisk will appear on the left side of the HUD when it is set as soy. With the HUD set as soy, you can cycle through the waypoints by pressing the HOTAS DMIS up or down commands repeatedly. Set waypoint 3 Copignati as your steer point. As you can see indicated on the HUD steer point data block, the HUD waypoint has a custom ID Copignati. If you cycle to the following waypoint, it also has a custom ID POTI. Mission waypoints are assigned the default ID of MSN XXX, where XXX is a numerical value starting with 001. Mark points are also assigned an alphabetical ID starting with A. Custom waypoint IDs can be created in the mission planner prior to the mission, or in flight by using the CDU waypoint edit functions. Waypoint IDs can also be used to search for waypoints in the CDU database. Make sure you have waypoint 3 Copignati set as the steer point, and we'll turn north toward it to continue our flight. I'm going to disengage the autopilot so you can make the turn.
Yeah, too late.
Autopilot is off. You have control.
Thanks, pal. There it is. Okay. Easy.
Autopilot is on. Let's review steer point indication presented to the pilot. Starting with the HUD, the destination index indicates the position of the current steer point as a small square. When not set elsewhere by the pilot, the current steer point is also the central point of interest, SPI. On the TAD page, the SPI is displayed as a wedding cake symbol currently corresponding with waypoint 3.
Yeah, there is.
In the bottom right corner of the HUD display is the navigation data block, which indicates information regarding the steer point. Starting with the top line, the following is displayed. Radar altitude valid through 5,000 feet AGL, steer point number and ID, steer point distance to go and target elevation, steer point time to go TTG, and time on target TOT delta, also current time. When a steer point has a designated time on target DTI, you can use the TTG and TOT numbers to make sure you arrive on time. In that case, you will also see a desired airspeed indication added under the airspeed indicator on the left side of the HUD. In the bottom center of the HUD is the heading tape, which indicates the current heading and desired heading bug to direct the pilot to the desired heading of the selected waypoint. When the steer point is outside the HUD field of view, the destination index will be latched to the side of the HUD in the direction of the steer point. To see this indication, set waypoint 4 Ponte as your steer point.
Okay. It's on the top right. Top right. Oh, so, yeah, okay, sorry. Not two, not
The destination index is now matched to the left side of the HUD. It includes two pieces of additional information: the degrees of turn remaining on top of the index and the steer point range under the index. If you change the speed from the steer point to a different location, the destination index on the HUD will change to a tadpole to avoid confusion with the target designation cue, TDC symbol. To see this indication, let's designate a speed point on the ground. Press and hold the hotest slew control down or the period key on the keyboard to slew the TDC down toward the bottom of the HUD. Then press and hold the hotest TMS up command or left control plus up arrow keys on the keyboard to designate a speed just ahead of the aircraft.
TMS up. Let's see what one that is. Forward. I'm sure that's what they mean by up. Tries to get the match. It's going to go on the left. Boom. Go up. Okay. Here we go. One up. Come on. Bottom of the HUD. Go further.
The HUD is now indicating both the tadpole destination index and the speed location as a TDC with a line leading to the total velocity vector. The tadpole is latched to the side of the HUD in the direction of the steer point, and the tadpole tail is indicating bearing to the steer point relative to your current position.
Yep, there it is. 0.9 miles away. It just says 0.9.
Let's now discuss the CDU. First, set the right MFCD as a CDU repeater. To do so, press the Hold Task Coolie Hat Right command, or press the K key on the keyboard twice to cycle the CDU page, or press the CDU OSB 13 on the right MFCD. As you can see, the right MFCD is duplicating the display of the CDU. We can now work with the CDU directly, or use the UFC and MFCD commands to view and edit CDU data. The CDU is currently displaying the waypoint page as indicated by the page title in the top left corner of the display. The top line also indicates the name of the currently active flight plan, F1 in this case, and the waypoint number of the steer point. The rest of the CDU display on this page is used to present data on the waypoint indicated on the third line, which is not necessarily the same waypoint as our current steer point. This allows you to view and edit waypoints without deselecting the active steer point information on the HUD and front dash instrumentation. For example, to view or edit the data for our current steer point, which is waypoint 4 Bolton, we can select this waypoint on the CDU by searching either for the waypoint number or the ID. Let's try searching for the number first. To do so, press the 4 key on the UFC. You will see the number appear on the UFC scratch pad at the bottom of the HUD and the CDU page of the MFCD. Then press OSB 19 to enter the number into search. You should now see detailed information about waypoint 4 Bote on the CDU, including the waypoint elevation, desired time on target, and coordinates. Note, as indicated on the bottom right corner of the CDU page, this is page 1 of 2 of the display. To see the additional information on page 2, press the function key on the UFC followed by the data down rocker key.
Data. Oh,
A2 displays additional waypoint information and options, including command steering indication scales, steering origin destination setting, desired time to go, desired time on target, and vertical navigation setting. Once you've looked over page 2 of the waypoint page, return to page 1 by pressing the UFC function key followed by the data up rocker key. Now let's try the alternate method and search for a waypoint by ID. Let's also try using the CDU instead of the UFC to enter the data. Using the keyboard buttons on the CDU, type in KOP as the initial characters of the ID for waypoint 3, Copignati, and then press the line select key R3 on the CDU to enter it into search.
Okay. Press the line select key, LSK, R3, right 3. LSK on the CDU, enter it into search. LSK. CDU. Alright. Display. Is it this? Yeah, I think it's that. LSK. select key. Line 3 on the CD. Okay, I'm just gonna make a keyboard shortcut for that right now. I'm gonna just put a 3 up here. I think it was this. Error. Oh, okay. That's L3. 3.
While we are working with the CDU, it's a good time to cover the important functionality of the steer point and page select dials on the Auxiliary Avionics Panel, AAP. The steer point dial selects between waypoint databases. When set to flight plan, the CDU will cycle through flight plan waypoints only. When set to mark, the CDU will cycle through mark points only. When set to mission, the CDU will cycle through all non-marked points in the database, including the flight plan waypoints. Note that the flight plan will appear on the TAD page only when the dial is set to flight plan. The page dial selects between main pages of the display. When set to waypoint, the waypoint main page will be displayed, indicating information on the selected waypoint. When set to steer, the steer point main page will be displayed, indicating information on the selected steer point. When set to position, the position main page will be displayed, indicating information on the aircraft's current position. The other page is used to edit data in the CDU. When not set to other, all of the other pages are read-only and no data can be entered into the CDU. Set waypoint 4 Poti as your steer point. I will disengage the autopilot so you can turn west toward waypoint 4.
Okay, but it already is.
Autopilot is off. You have control.
Warning, autopilot.
Okay. $45 miles. Sure didn't miss anything. Okay. Alright. Let's get the landing one to go.
Welcome to the landing training mission. In this mission, we'll practice landing procedures in the A10C using an instrument landing system ILS approach into Batumi Air Base. I've engaged the autopilot to keep us level and on course. Maintain airspeed around 200 knots as we prepare the aircraft for the approach. If you find it hard to hear my instructions over the background noise, exit the mission and turn down the world and in-cockpit sound sliders to about 50%. Landing is one of the more challenging aspects of any flight. A good landing will require careful control of the aircraft and use of various instruments in the cockpit for a precise approach under the direction of the Airbase Air Traffic Controller ATC. A landing consists of navigating to the destination airfield using TACAN or GPS navigation, configuring the radio to the airfield's ATC frequency, configuring the ILS receiver to the airfield's ILS frequency, navigating to the final approach fix as directed by ATC, and finally performing the final approach to fly the aircraft precisely down the glide path toward the touchdown point of the runway. Press the spacebar key when you are ready to begin. Because we covered TACAN navigation previously, we'll use the GPS component of the IGI to navigate to our destination in this lesson. The CDU divert page lists the 4 closest air bases programmed in the CDU as selectable waypoints. To access this page, let's first open the CDU page on the right MFCD with OSB 13. Now open the CDU nav page by pressing function followed by the 2 nav key on the UFC. Press OSB 10 to open the divert page. The divert page displays the closest 4 air bases with their corresponding bearing, range, and time to go numbers. Press OSB 16 to make Batumi Air Base your steer point. You can now use the navigation data block in the bottom right corner of the HUD to monitor the range and TTG to home plate. As indicated on the CDU FLD info field info page, the ATC radio frequency for Batumi is 131.000 MHz. We now need to set our VHF AM radio to this frequency. Press the spacebar key to proceed when the VHF AM radio is tuned to 131.000. Good. We can now contact Batumi ATC for initial approach instructions. However, before we do this, let's also set up the ILS panel for the approach. ILS is a ground-based precision approach system that guides approaching aircraft to the runway using vertical glide slope and horizontal localizer radio signals. ILS beacons operate at specific frequencies that need to be tuned to by the approaching aircraft. Batumi ILS operates on 110.30 MHz. On the ILS panel, roll the mouse wheel over the left frequency wheel to first set the frequency to 110. Now roll the mouse wheel over the right frequency wheel to set the frequency decimal to 0.30. Power up the ILS receiver by right-clicking over the left frequency wheel. Let's now check in with Batumi approach and call our flight inbound. Press the HOTAS mic switch forward command or left alt and num plus keys on the keyboard to open the VHF AM radio menu.
Okay, HOTAS mic switch forward. Let's program that. Don't have that yet. No, that's definitely not what I want. That's what I want.
Now press F5 to select the ATC radio page, then select Batumi approach, and finally F1 to call inbound. Take note of the inbound instructions you will receive. Press the spacebar key to proceed once you've received the vector to the final approach fix from Batumi ATC.
Batumi, Hog 1-1, inbound. Hog 1-1, Batumi, flying heading 232, port 40, QFE 29.89, runway 13, to pattern altitude.
Press the escape key on the keyboard to exit the radio menu. We'll return to it in a few minutes. We can now navigate to the final approach fix, which will be approximately 10 nautical miles off the runway. Pattern altitudes vary depending on the airbase and local conditions, but are generally between 2,000 and 3,000 feet ATL above ground level.
Warning,
Whenever you're ready,
autopilot.
press the spacebar key and I will disengage the autopilot so you can make the turn to the heading provided by ATC. Autopilot is off. You have control.
Warning,
Turn to the heading
autopilot.
provided by ATC. Maintain altitude. We also need to set the HSI course to the runway heading of 130 degrees in order to get correct CDI indication for final approach. To do this, roll the mouse wheel over the HSI course set knob to set the HSI course needle to 130. Alternatively, you can press and hold the left mouse button while dragging the mouse left or right to turn the knob. Watch the HSI bearing window for the exact bearing. Let's also scale the TAD map out a bit so you can see the airbase steer point on the map as we approach. Make the TAD soar by pressing OSP 15 on the left MFCD, then press HOTAS DMS down or the N key on the keyboard twice. Set the HUD as soar by pressing the HOTAS coolie hat up command or the U key on the keyboard. Because you'll want to concentrate on flying the aircraft once we turn on final, let's discuss now what will happen as we near the final approach fix. You want to hit the approach fix at approximately 2,500 feet and 230 knots indicated airspeed. As you approach the final approach fix, the CDI needle on the HSI will begin to move down toward the course needle. We will turn toward the runway to keep the two needles aligned to pick up the glide slope along the runway heading. As you turn, you will bleed off speed to below 200 knots and extend the landing gear and flaps for landing. Press the spacebar key to proceed when ready.
Approach fix. 500, 230 knots.
Once the ILS signal is picked up by the ILS receiver, the glide slope deviation indicator will appear on the ADI. You will need to center this needle by gaining or losing altitude to see the pitch steering bar on the ADI for precise pitch control down the glide path. The bank steering bar will also appear on the ADI for precise directional control. Press the spacebar key to proceed when ready. Once established on the glide path, use the angle of attack indexer to maintain on-speed approach, around 120 knots or slightly less, because we are coming in light today. On the AOA indexer, the up arrow light indicates speed is too fast. The down arrow light indicates speed is too low. The O donut light indicates proper speed. If both the donut and an arrow light are on, the speed is only slightly off from on speed. Press the spacebar key to proceed when ready. In addition to ILS, Batumi Air Base is equipped with a Position Approach Path Indicator PAPI light system. PAPI is designed to assist the pilot in maintaining the glide slope during final approach. It consists of 4 lights lined up horizontally near the runway threshold. The lights indicate either red or white. Your goal is to see 2 red and 2 white lights going from left to right. More red means you are below glide slope. More white means you are above glide slope. Press the spacebar key to proceed when ready. We'll keep the aircraft on autopilot until we get a little closer to the approach fix. If you wish, you can press left control and Z keys to accelerate time. Press left shift and Z to return to normal time.
It's alright.
We are now approaching the final approach fix. Select ILS mode on the dim sill. The red glide slope warning on the ADI indicates that we are not currently receiving an ILS signal. The flag will be stowed and the glide slope deviation indicator needle will appear when we are closer to the runway. Whenever you're ready, press the spacebar key and I will disengage the autopilot so you can descend to pattern altitude. Autopilot is off. You should by now see the Batumi runway at about your 10 o'clock.
Warning,
When the runway
autopilot.
is closer to your 9 o'clock, you will be nearing the approach fix. Check that the anti-skid switch is set to on. Descend to 2,500 feet. Maintain between 230 and 250 knots. The CDI is moving toward the course arrow on the HSI. Turn left toward the runway. Reduce power to begin gradually dropping your airspeed toward 200 knots and below. If you overshoot the runway heading, perform a course correction in the opposite direction to realign the CDI with the course arrow. The glide slope deviation indicator indicates that you are below the glide path. Pick up some altitude to center the needle. If not already done, set the aircraft to landing configuration. Set the flaps to the down position by pressing the F key twice, and lower the landing gear by pressing left shift and the G key on the keyboard. Fly the aircraft to keep the pitch and bank steering bar centered on the ADI. Monitor your airspeed to maintain approximately 120 knots. Batumi approach is now transferring us to Batumi Terminal Control for landing clearance. To request landing, press the HOTAS mic switch forward command or left alt and num plus keys to open the VHF AM radio command menu. Then press F1 to request permission to land. Once cleared, press the escape key to exit the radio menu.
Batumi, Hog 1-1, request landing. Hog 1-1, Batumi, cleared to land, runway 13. Wind 240 at 3 meters per second.
Uh-oh. Okay.
The AOA indexer is indicating your speed is high for the approach. Increase AOA by pitching the nose up or reduce engine power to slow down. If need be, you can open the speed brakes by pressing and holding the left control and B keys. To retract the speed brakes, press and hold the left shift and B keys. As you approach the runway threshold, the pitch steering bar on the ADI might begin to oscillate slightly. Do not chase the needle. Maintain the glide slope to the touchdown point.
Altitude, altitude.
Come on. Zoom tight.
As you near to just a few feet above the runway, reduce engine power to idle and gently pull the stick slightly back to flare the aircraft.
Easy.
Touchdown. Now lower the nose for nose gear touchdown. Use the rudder or X and Y keys to keep the aircraft running down the center of the runway. Engage the wheel brakes by pressing and holding the W key. Once your speed is reduced to below 70 knots, engage nose wheel steering NWS by pressing the HOTAS pinky button or the insert key on the keyboard. Taxi off the runway using one of the taxiways to the left. When taxiing, avoid holding down the wheel brakes while turning at the same time. Keep the ground speed under control to avoid damaging the tires, gear mechanics, or tipping the aircraft to either side.
Hog 1-1, taxi to parking area.
Follow the taxiway line to the parking spot. Looks like the crew chief is on his way over there now. We'll now shut down the aircraft. First, set the anti-skid and pedal tube heat switches to off.
There it is.
Turn off the ILS receiver by right-clicking the left frequency dial knob. Turn off the IFC and the kick cue on the AHCP. Turn off the left and right MFCDs. Turn off the countermeasure system. Retract the flaps to the up position by pressing left shift and F twice. Turn off the IGE and CDU on the right console. Spool down the left engine by pressing the right Alt and N keys. Monitor the EMI panel to check for a safe spool down. The core RPM should drop down to 0 and the ITT to approximately 200 degrees. Anticipate a slight heat soak back as the engine stops.
There's got to be a canopy up. Levers somewhere.
Now spool down the right engine by pressing the right control and N keys.
Very cool.
Set the inverter switch on the electrical panel to off. Turn off the battery. Turn off the VHF AM, UHF, and VHF FM radios. This concludes the landing training flight. Press the escape key to exit the mission.
Yeah, baby. That's how we do it. Good stuff. Alright. That's where I'm gonna end it. Alright, thanks for watching. See you on the next one.